Forget the sun, that raging hydrogen furnace. Forget the chilling fury of a nuclear bomb, tearing apart atoms. These are child's play. These are clumsy, inefficient sparks. Because out there, in the cosmic darkness, lurks the universe's ultimate secret, a power so profound, so utterly efficient, it makes every star in the sky look like a flickering candle. Imagine a single gram of pure, unadulterated energy, not converted, not split, but annihilated. 1 gram, enough to vaporize an entire city, enough to propel humanity across light years in a blink. It's the universe's perfect twin, a cosmic mirror, waiting for the slightest touch to ignite an explosion that screams, erupt. This isn't theory, it's terrifying reality. But what is this phantom twin? And why is it the most powerful, most dangerous substance in existence? All right, lean in. This is where the universe reveals its true terrifying genius. Imagine for a moment, not a simple reflection in a mirror, but a complete, perfect inversion of reality. That's antimatter. Every particle we know, every proton, every electron, has an exact ethereal twin, an antiproton, a positron, identical in mass but with an opposite electrical charge, an inverse spin, a fundamental counterpoint to everything that makes how-less. They are the universe's ultimate rivals, designed for one purpose: to erase each other. And when these cosmic twins finally meet, it's not a collision, it's a dissolution, a cosmic vanishing act so profound, so utterly complete, it shatters your very notion of existence. Poof, gone. Matter and antimatter, together, simply annihilate. They don't just bounce off each other, they don't just fuse, they cancel out, vanish, and in their place, pure unadulterated energy. Not heat, not light, not radiation, just raw, screaming energy, unleashed in its most fundamental form. This is where Einstein's chillingly elegant equation, E=mc2, screams its loudest truth. It declares that mass is energy, and with antimatter, you don't just tap into a sliver of that energy, like in a sputtering nuclear reactor, which might convert a pathetic 0.1% of its fuel. You don't scrape a few crumbs, like in a fission bomb, which barely scratches 0.07%. With antimatter, you get all of it, every last screaming jewel. It's a 100% conversion rate. Think about that for a moment. 1 gram of antimatter colliding with 1 gram of matter. That's 2 grams of total annihilation. The energy unleashed from that minuscule encounter, it's enough to make the largest thermonuclear bomb ever detonated, the Tsar Bomba, look like a damp firecracker. The Tsar Bomba, a monster that could level an entire country, harvested its power from a tiny fraction of its fuel. Antimatter devours itself completely, leaving nothing but pure, unchained power. It's the universe's ultimate strategic move. Maximum impact from minimum mass. It's the theoretical engine of starships, the ultimate power source, and the most terrifying weapon you can possibly conceive. So, if antimatter is this cosmic cheat code, this ultimate power source, why aren't we strapping antimatter drives to starships and lighting up cities with a few milligrams? Ah, my friends, because the universe, in its infinite wisdom, gave us the perfect solution, but hid the key in the most impossible lock imaginable. Creating and containing antimatter is humanity's most audacious gamble against the very laws of physics. It's a Herculean task, a quantum ballet performed on the knife edge of annihilation. Think of it this way: to create antimatter, you need colossal amounts of energy. We're talking about smashing particles together at near light speed inside gargantuan machines, like the Large Hadron Collider at CERN. It's like firing 2 bullets at each other from opposite sides of the planet, hoping they'll collide perfectly to produce a single, ephemeral spark. When protons collide at unimaginable energies, for a fleeting instant, the raw energy of the impact can actually condense into new particles and their antiparticle twins. But these aren't just sitting there waiting to be scooped up. They flash into existence for a microsecond, desperate to find their matter counterpart and unleash hell. The real strategic deep dive, the true chess game, comes in containing This cosmic fire, antimatter cannot touch anything made of matter, not glass, not metal, not even air. The moment it touches anything, it's gone. Boom, annihilation. So, how do you hold something that instantly erases what it touches? With pure, unadulterated force fields. Specifically, with magnetic bottles. At CERN, brilliant minds are engaged in this impossible feat, using supercooled superconducting magnets to create intricate magnetic traps, Leviathan-sized invisible cages designed to suspend these antiparticles in a perfect vacuum. They float, isolated, never touching the walls of their prison. The anti-hydrogen laser physics apparatus, or ALPHA experiment, is a shining example of this desperate struggle. They've managed to trap anti-hydrogen atoms for over 16 minutes, an astonishing amount of time in the subatomic world, but still a blink in the grand scheme. And how much antimatter? Are we talking about grams? Kilograms? Oh, my dear friends, no. We're talking atoms. A few dozen, maybe a few hundred. The entire amount of antimatter ever produced by humanity could barely light a single light bulb for a few seconds. It costs quadrillions of dollars per gram to produce, making it, by far, the most expensive substance in the known universe. We expend the energy of a small city to coax a handful of antiatoms into existence, only to hold them in a magnetic embrace that screams with effort. It's an unwinnable game, yet we play it because the prize is nothing short of cosmic mastery. If the sheer audacity of this scientific quest, this relentless pursuit of cosmic secrets, ignites a spark of wonder in your own mind, then smash that like button. And for more journeys into the universe's most mind-bending mysteries, be sure to subscribe and join our cosmic crew. Now let's unleash the thought experiment. If we could somehow overcome the astronomical challenges of production and containment, what then? Antimatter isn't just a scientific curiosity. It's a double-edged sword, gleaming with the promise of unimaginable power and the threat of ultimate destruction. Picture this: the Visionary's Gambit, a spacecraft no bigger than a small car, accelerates to a significant fraction of the speed of light in mere days, not years. No massive fuel tanks, no sputtering rockets, just a tiny pellet of antimatter, annihilating against a matter fuel, propelling a magnetic nozzle with pure energy. Interstellar travel, once relegated to the realm of science fiction, becomes a terrifyingly real possibility. We could reach Alpha Centauri, our nearest stellar neighbor, in mere decades, not millennia. Humanity could burst out of its solar cradle, a truly multi-stellar species, all thanks to the terrifying efficiency of matter-antimatter annihilation. Imagine power plants that could run entire cities for centuries on a speck of dust, leaving no waste, no emissions, just pure, clean, boundless energy. This isn't just a power source, it's a paradigm shift, a cosmic liberation from the shackles of finite resources. But here's where the cosmic strategist must play out the darker possibilities. The strategic deep dive into the game theory of annihilation. The same power that could lift us to the stars could just as easily tear apart our very world. 1 gram of antimatter, strategically delivered, could unleash the equivalent of a dozen Hiroshima bombs. A few grams could obliterate a major metropolis, leaving nothing but a superheated crater. Forget conventional warfare. Forget nuclear deterrence. A weapon powered by antimatter would be the ultimate cosmic checkmate, a silent, unseen threat that renders all other armaments obsolete. Imagine the geopolitical nightmare. The race to master antimatter wouldn't just be a scientific endeavor. It would be the most dangerous arms race in human history. Nations wouldn't be vying for nuclear supremacy, but for annihilation supremacy. The fear wouldn't be of a mushroom cloud, but of a blinding flash that leaves no trace, no survivors, just a void where a city once stood. The technology to contain it, to manipulate it, would be the most closely guarded secret, held by those who wield the power of instant, absolute erasure. It's a power that demands not just scientific genius, but an unprecedented level of moral fortitude, a global maturity we are perhaps not yet ready to possess. The dream of interstellar travel and limitless energy walks hand in hand with the nightmare of absolute destruction. It is the ultimate gamble, the highest stakes imaginable. So we have this cosmic twin, this annihilating mirror image of everything, and it begs the ultimate question. the universe's most profound detective story. If antimatter is so fundamentally intertwined with matter, if every interaction, every burst of energy in the early universe should have produced equal amounts of both, then where is it? Why is our universe, the one we inhabit, the one where stars blaze and galaxies spin, and we exist, almost entirely made of matter? This isn't just a missing sock. This is the case of the missing cosmic twin, the Big Bang. That incomprehensibly energetic genesis should have been the ultimate party for matter and antimatter, for every proton, an antiproton, for every electron, a positron. They should have been born in perfect symmetry, destined to meet, cancel each other out, and leave behind nothing but a sea of pure energy. And yet, here we are, a universe teeming with galaxies, stars, planets, and people. A universe overwhelmingly dominated by matter. Where did all the antimatter go? Or more precisely, why is there even any matter left at all? This is the greatest cosmic paradox, the fundamental imbalance that underpins our very existence. Astronomers and physicists, like cosmic detectives, have been hunting for clues for decades. We've searched for anti-galaxies, anti-stars, anti-planets. We've sent probes, peered through telescopes, listened for the telltale gamma-ray signature of matter-antimatter annihilation on a grand scale, and found almost nothing. A few fleeting positrons from cosmic rays, a handful of antiprotons from high-energy collisions, but no vast cosmic reservoirs of antimatter. It's as if the universe in its infancy played a trick on itself, or perhaps made a crucial, asymmetric choice. The leading theory, the one that keeps astrophysicists up at night, is that for every billion pairs of matter and antimatter particles created in the Big Bang, there was a tiny, infinitesimal excess of matter. Just one extra matter particle for every billion annihilation events. 1 in a billion. And that tiny, seemingly insignificant surplus is everything. It's the reason we exist. It's the reason stars ignite, and planets form, and life can emerge. But why that asymmetry? What fundamental law of physics allowed this minuscule imbalance to occur? Is there a subtle difference in how matter and antimatter decay? A tiny violation of CP symmetry, as hinted at in particle accelerator experiments, where the laws of physics aren't perfectly symmetrical for matter and antimatter? Or perhaps there's a deeper, stranger mechanism at play, a cosmic sleight of hand that ensured our universe wouldn't be a sterile sea of photons, but a vibrant tapestry of stars and life. The search for this answer is the universe's ultimate cold case, and solving it could unlock secrets about creation itself. It's the greatest mystery, screaming from the silence of the cosmos. Why are we here? Antimatter, a concept born from equations, forged in the heart of unimaginable energy, and held captive by the most extreme magnetic fields known to science. It is the universe's ultimate power, a double-edged sword that promises cosmic travel and threatens absolute annihilation. It is the ghost of creation, the missing piece in the grand puzzle of why anything exists at all. We stand at the precipice of understanding, grappling with forces that could redefine our future, for better or for worse. The pursuit of antimatter isn't just a scientific endeavor. It's a profound philosophical journey into the very fabric of reality, pushing the boundaries of what it means to be alive in this astonishing, asymmetrical universe. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion.